Thanks again. My name is Nick Perry. I work for York Peninsula Council, Manager of Economic Development. It's our pleasure to have you all along tonight to hear from some experts in this field to talk about the algal bloom that's having such an impact on York Peninsula. We'd like to start tonight by acknowledging that the algal bloom is also obviously devastating our sea country, and that's very important to our Narungga people. I'd like to introduce Sonia Rankin for tonight's Welcome to Country.
Nayungunik, Namani, Nai Narangangi, Nai Graracha, Naranga Wara Wongacha, Mani Naranga no Bangara, Bani Nalagu Wadley, Bani Nalagu Yarda, Nalagu Pukipukulu Mana Bacha, Nadlu Bamari, Badna Angi, Yardley, Nari, Wogani, Nalagu Wambana, Yungu, Nalagu Dagri, Nalagu Gungore, Nayungu. Hello everyone, I am a Narungga woman and I'm proud to be speaking Narungga language. Welcome to Narungga country. This is our home, this is our land, our heritage is strong. We have come as all people to walk as one and share our experiences and our future is in our children. Thank you. I'd like to just add that for what we're here for today, Nalagu Yardlu Warana. Our sea is sick, and that is why we're all here today, to find out more and how we can care for our country and for our sea. Nayungu.
Thank you very much, Sonia. Special mention tonight to member for Narungga Fraser Ellis, who is here, as well as some of our elected members, Councillors Trevor Clerk, Nick O'Connell and Tanya Stock. We do have apologies from member for Grey, Tom Benning. I can see Councillor Roger Johns there as well. Sorry to anyone I've missed, they were on the registration list. Apologies from member for Grey, Tom Benning, as well as Council CEO Andrew Cameron and Acting Mayor Richard Carruthers, who are away on other local government duties tonight. Some very quick housekeeping. We have toilets through there, and the format tonight will be that I'm about to introduce Faith Coleman, who will then pass over to Anita Thomas, and then we'll take some questions until about 6:25 when we start to wrap things up. So again, really appreciate everyone's attendance tonight. Hope it can be very informative. I think we've got the best people possible to give you this sort of science-based update on where we're at with the harmful algal bloom. So please welcome Faith Coleman.
Okay, good evening. I acknowledge that I'm on Narungga country and thank you for the welcome. Alright, so I'm here because we have an algae bloom, which we're all very, very aware of, and we're all having to deal with in our own way. And the York Peninsula, amongst many of our other really important sea countries, is possibly one of the worst hit, or next to Kangaroo Island as one of the worst hit areas. And so, at least the eastern side of it is. And so, the council workers, Letitia and I, had a conversation about me coming here and having a chat to you about what it is in the water that is sick. And I've brought along with me Anita, who will talk to you about what we can do in the long term to try and fix it. Okay, this amazing diagram behind me was This amazing diagram was drawn by one of our PhD researchers in one of the local universities. She's doing lots of work on sharks, and she figured one of the biggest challenges with this bloom is that the species, we can't see it, we can't feel it, it's really hard to understand what is wrong. And so she has been drawing these amazing cartoons to try and give everyone an idea and an identity behind the bloom species. And so Chloe Williams drew that for me, and on one side is the sea sparkle, the Noctiluca scintillans, and the other side is the Carinia. And I thought I would start by pointing out that not all blooms are harmful. We've spent a lot of time talking over the last 3 or 4 months about blooms being a horrendous thing. And they can be, but they are also a wonderful thing. So the blooms we get in our gulfs, the gulfs have always been prone to blooms. The upwelling down the southeast, closer to where I live at the moment, is very prone to blooms. There's one behind me on the screen, which was the upwelling last year, down the southeast, the Bonnie upwelling. The thing is, those blooms are made of different species. And it doesn't take much to choose from one species to another. And so this one was a series of diatom blooms. And the reason they're important is when they're in large blooms like this, there's a little crustacea called a copepod that comes in and eats them. And these giant animals, called whales, come in and eat them. And so without blooms, we wouldn't have whales. Without blooms, we wouldn't have an awful lot of things. And so it's also important, although we need to work out how to deal with this, we have to do it in a way that doesn't damage those things that are also of value. This bloom has been particularly challenging. So both one of the most amazing things about this bloom in comparison to the last, what we call a mega bloom, a bloom across both of the gulfs. We had one in 2013, which included this species amongst others, is that we didn't have citizen science, so no one knew what it damaged. And so the amazing thing with this bloom is we started very early on with people reporting it on iNaturalist. We've now got 14,000 records or more on iNaturalist of dead fish and animals that last time we had a mega bloom, it wasn't as bad as this one, it didn't last as long, but we had 20 records. So that tells you the difference between a community being aware and not being aware. And that is incredibly important. And I know in this region, a fellow by the name of Lockie did a lot of that work. Janine also did a lot of work. The York Peninsula has disproportionately done an awful lot of the community awareness work, of the documenting what's wrong. So I think that's something that this community should be incredibly proud of. Now, when we talk about an algae bloom, sometimes when we say that, people think we're talking about large amounts of stuff that rocks up on the shore. In this case, it's something so small we can't see. So, marine phytoplankton is everything that grows and photosynthesizes in the marine zone. And we have about 5,000 species out there. So every drop of water that is in your Gulf, there can be literally hundreds of species in every drop. And so it's a whole different world. I visited some folk today and we're looking down a microscope to show them what was in the water here. It is really quite remarkable that there's a whole diversity that no one's aware of. Of those, less than 2% are harmful species that we know of. And so that just gives you an idea of the difference. We're dealing with a very small portion of the community. From that 5,000 odd species, about 800 of them are something we call a dinoflagellate, which is a word some of you may have heard and some of you may not have. A dinoflagellate is a little single-celled organism. Some people would say algae. In fact, it is an algae, but it's a bit weird. And it's about 20 microns long. There's 1,000 microns in a millimetre. And so they're 20 microns long, so they're a tiny, tiny portion of that size. Now, a dinoflagellate, you can tell because it has two flagella, and it wraps one around its waist, and it puts one above its head, and it swims that way. And so they're highly motile. And we know that about this bloom in the fact that they will go, now we have documented it, down to 30 metres into the water profile. Which brings us to something else about dinoflagellates. Not all of them need to photosynthesize. In fact, some of them don't even have chlorophyll. And so the species that we have here, the Corinias, and you've got a mix of them here at the moment, actually survive off eating other things. And so most of your Corinia are what we call mixotrophic. They go around in the water, swimming around, and they get a large portion of their nutrients, not from photosynthesizing, but by eating dead, organic, rotting stuff in the water. And they eat other bacteria and other algae. And so it's worth, when we're talking about controlling them, realising that they're somewhat different to most. They also produce allopathic compounds, so they kill things around them, so they don't get competition. And while doing that, one of their closest relations is the giant kelp and the rockweed that many of you have, and so they're actually causing health issues to your rockweed through their allopathic compounds. They don't mean to. It's something they do to get rid of the other plankton, but they get rid of the rockweed while they're going through. The picture behind this is a picture of the Crinia mikimotoi that hit the Coorong, and it's probably one of the clearer photos that we have to date. She's quite a characteristic little critter. At the moment, the bloom seems to be moving, and the intense area of it is about 4,500 kilometres. The overall impact area is a lot larger than that. The highest counts we've had is 76,000 cells per milliliter, with most of your counts now a lot lower than that, mostly in the hundreds of cells per milliliter. There is a lot of cells when you add it up. It's 45 quintillion cells, we believe, are in this bloom at any one point in time. That is 45 million cells. It's 150 million times more cells than there are stars in the Milky Way. Okay, so it is huge. They're tiny, but there is a huge number. And getting a scale of this bloom is incredibly hard. When we talk about the Gulf's flushing, we're talking about trying to get rid of something, a body of water that is 4,500 square kilometres and 20 metres deep, or 30 metres deep, as we're finding. So the important thing is, why do we get blooms? We get blooms mainly because something changed. So when we talk about the various causes for this bloom, and people talk about nutrients and all the rest, what we usually find with a dinoflagellate is we get a dinoflagellate after a large number of other things have died. And so we get a shock, and that is the species that takes over. Which species takes over is a game of Russian roulette. This time we got this species. In your Gulfs, there's 60 hazardous algal bloom species. We have about 30 or 40 of them present at all times. Okay? And so all you need is a stressor, and it's a rough game to see which one pops up. So the easiest thing is not to stress the system. Easier said than done. Each different species has different preference around pH, EC, carbon dioxide. Diatom blooms, which are a little glass-coated algae. So if you can imagine a little single-celled algae, but they coat themselves, they make glass by wrapping themselves in silica. They require high amounts of nitrogen and phosphate in something what most farmers would recognise when I said the Redfield ratio. It's a particular ratio of phosphate to nitrate. If that water and that nutrient is out of balance and you have more phosphate than nitrate, you get cyanobacteria. And if there isn't a lot of bioavailable nutrients, not a lot of nitrogen and phosphate, what you get, if there's lots of rotting organic matter, is a dinoflagellate. And so it's those sorts of things. Increased CO2 also leads to dinoflagellates, and increased iron leads to dinoflagellates. Okay? And so because the fact that we have more CO2 in the air, we've got dinoflagellates. And pretty much all around the world at the moment has dinoflagellates. In fact, I have 6 clients in 12 countries that have dinoflagellate blooms right now. Okay? You are not alone. Not alone in any sense. This is a worldwide phenomenon, and although it's a terrible species that you have here, it is not the worst. And so there's at least 20 species worse than this one. And I didn't think I would ever say that, but that is where we're at the moment. Now, this is a picture of Australia and its sea temperatures. And what it is the anomalies, how much higher above the average sea temperature for this particular time of year. This particular time of year is the start of January this year. And what you can see is my home country, which is all the way up there at Dampier in West Australia. is really, really hot. It is so hot up there now and in January that the seagrasses are cooking and our dugongs are starving. Okay, so we have fish floating around in our water dead through Ningaloo and through Exmouth Gulf. And the largest seagrass plant in the world, a Posidonia there, that is thousands of years old, it's the largest living organism in the world, is dying back. Okay? And this has been going on now for 18 months to 2 years up there. And what we watched as the year progressed is this heat wave over the last 18 months has wrapped its way around this side of Australia. And you can see in this one, there's a little spot just down near Robe. So if you look here, that colour there correlates to 3.5 to 4 degrees hotter than normal for that time of year. And the reason it was so hot there is the Bonnie upwelling didn't start. Well, it did twice, it tried, but never really made a proper go of it. And that led to record heat throughout our Gulfs. But right there's a whole heap of rockweed and kelp that requires those colder temperatures. It's used to those colder temperatures. Every January, it gets Antarctic-sourced ocean currents blowing across it. Robe is always cold. And that is why, and it wasn't this year. And what the fishermen down there noticed is that their seagrass died in January. In fact, it started dying off in November, but it died en masse in January. The shark fishermen down there haven't fished since January, and they haven't, and they got all of the symptoms that they got at Minlaton, plus they got large boils on their arms from another source. At Robe and Beachport. And so that's been going on since then. The fishermen tell me they are yet to catch a proper catch, although they're hoping soon. It's starting to look better. And of course that, after that started there, it just has wrapped from Minlaton, it's from Boatswain's Point up to Minlaton, which became where everybody noticed it, of course, because the funny thing, if a tree falls in a woods, did it actually happen? Did it make a noise? And it's the same with environmental things. In this case, no one really noticed until it hit Minlaton. And that's when I got a phone call to come talk to them about that in March and April. And then you guys got hit not long after that. To give you an idea of the scale of this heat that's in the sea, there's two things. One of them's a photograph of a friend of mine's laptop because, he's doing this in the middle of the night and many people are. All of the brick red things on this diagram are areas of South Australian marine zone that are the hottest ever on record. Okay. All of the areas with light orange are the second hottest in record, with the hottest year on record being 2013 when we last had a mega bloom. Okay? And the one before it, so the blue one, is where there's been a hotter year on 2 years. The other year being 1984, which non-coincidentally was another mega dinoflagellate bloom. Okay? The correlation is very close. And this here is, for that area there in the Gulfs, the average ocean temperature. And you can see it starting here in the 80s, and progressing up to this year. And this is this is January to March numbers, so it's just the period that the bloom, numbers. So it's just the period that the bloom's been here. But not only has it been trending up, but it has this immense variability. It was colder the year before we had a mega upwelling, and then we got this. So all of the plants in the water column got really badly shocked. And once again, that high variability also correlates to every single mega bloom we have had that we know of. We only know of those three, and they're getting worse every time, so we'd rather not have a fourth, okay? And of course that shows in the chlorophyll maps, and you can see it moving. So these are the early chlorophyll maps. The thing about chlorophyll is it shows everything that is using light, everything that is photosynthesizing within 10 metres of the surface of the water, roughly, usually. And you can see it started in February. Ideally, these gulfs would be a light blue on this index, You can see in February, at March, you can just see it starting to get worse at Minlaton. We actually watched it go up, and you can see the Gulf starting to go from blue to this greener colour because they are so hot. But you can see the upper Gulfs are always red, and they're red because there's mudflats, there's seagrass, there's lots of other things. So you don't always assume that it is an algae bloom when you see these. But you can see it moving through March as it progressed through Minlaton, Kangaroo Island, started hitting the York Peninsula, 3rd of April, you're fully engaged, and a piece of that bloom spiralled up and went up through to Stansbury and so forth as you move your way across. So this is the more recent ones moving on since there. You can see that the bloom has actually died down a bit, but it's a lot shallower, so it's brighter. The concentration actually has other phytoplankton in it now. But you can see on these that we have a bloom of something, but not this, at Coffin Bay. Okay? In fact, we have blooms of other dinoflagellates all the way across to West Australia in each of the bays up through. You can see them up through Sejuna and stuff. There's other blooms of other species. I don't have samples, no one's brought me one, so I have no idea what they are mostly. Coffin Bay had a bloom, and you can see right up the side of the Eyre Peninsula now has fully engaged with the bloom. We're seeing it right through Tumby Bay, and we're seeing the first deaths at Cowes now. So, yeah, it's been a long few months. But you can see over this side, and I'll explain why later, that Hardwick Bay in here does have a big seagrass bed. It's present in many of them, and so it does show higher. It is engaged with the bloom, as in it has low numbers, but not a lot. And there's a few reasons for that. One is the seagrass and one is the salinity. I'll show you next. But you can see Gulf Vincent is fully engaged. One of the reasons that different areas do and don't engage, and why you didn't get a bloom in the Spencer Gulf earlier, is because the one thing that really does seem to keep this one under control is salinity. So it's not perfect as a control, but it doesn't seem to like blooming at least above 37.5 grams per litre, and it is that exact. It will tolerate it in low numbers. And so what you can see here in this diagram, the first image was about a month ago, and the next image was a couple of days ago. And so when the bloom first started, the entire Gulf was red because it was high salinity. 37.5 currently is there. Okay, and so you can see this coming in as low salinity, and it's the areas where it's impacted. And once again, back a month and a half or so ago, this area of your peninsula was impacted, but it wasn't up at Price, and it wasn't up at Port Wakefield. But you can see now, in these last few days, that you've almost entirely lost the solid red at the top, and the 37.5 is a couple of steps above that. And so basically the entire Gulf St Vincent is engaged now. And the Adelaide beaches. It often comes up about whether it's cold enough yet. And so this is a temperature graph. Once again, it's from a couple of days ago. We know that to bloom, Corinnia really likes it to sort of be above 16 or 17 degrees, 18 degrees. That orange stuff off the shore here is the marine heat wave. Okay? So that wraps all the way around the coast. And the deepest orange is 20 degrees. And that's just on the surface, it's deeper underneath. Okay? So it's hotter as you get deeper into the profile. It's cold on the surface at the moment because it's cold outside. And what this is doing, or what it seems to be doing, is preventing the flushing of the Gulfs properly. Best we can tell, that current is preventing the... You know how many of the Saudi researchers said, we'll get a storm, it might flush it? Well, they were hoping that those currents would come, but they've been nowhere near as strong this year. The current forecasts from Saudi, I'm not an oceanographer, are saying it's unlikely for us to get properly flushed Gulfs for another 12 months. And so there is, unless the bloom numbers, the Corinnia Mikimotoi numbers and its close relations get lower than they are within the next few weeks. We're almost guaranteed to have another and potentially worse bloom in spring, summer, autumn. And so it's worth keeping in mind that we need to plan for that, even though we hope it won't be. We're hoping there is still a percentage chance, maybe 20, maybe 40% chance that this will break this winter. And that is what I think many of us are hoping for. But the odds are it won't. And so we have to plan accordingly. And so we have to advocate incredibly strongly to government agencies to make sure that we have the support packages in place that are needed. The next slide is a conversation about the start of finding a solution so this doesn't happen again. In 2013 we had a mega bloom that impacted both gulfs, but the reason it broke, and you didn't hear about it, is because there was a huge diversity of plankton in the water column. That diversity of plankton allowed for the suppression of the hazardous algae species. Okay? We don't have that with this one. It is almost exclusively Carinia. And the reason we don't have that diversity is we don't have the bed creek life, we don't have the cool shaded creek lines and salt marshes and kelp beds and seagrasses and oyster reefs and other things that we once had. And so those things are incredibly important because they keep the water cooler, because they keep it clearer, and that gives us a resiliency that we wouldn't otherwise have. And so that's why the next presenter is someone I'm hoping you know incredibly well, or if you don't, you should. And I'm going to swap over the person she's holding in her arms. It's a lady called Anita Thomas, and she helped build she was captain in charge of building the oyster reefs just off Ardrossan. Can you please welcome to the stage Anita?
Thanks so much, Faith. Faith's been leading this and doing such an incredible job at being at the forefront of this, and trying to also look after her family and run her business. And so we're incredibly grateful for her to have stepped forward to do that. I also acknowledge that we're in Narungga country, and also acknowledge any Narungga or First Nations people in the room today. And I just want to touch upon something that Sonia said about the ocean being sick. I think it's something that we're all talking about and saying. And in my past life, I used to work at an aquarium store, and I kind of like explained this to people that it's kind of like if you've ever looked after a fish tank. There are things that you do to look after the health of that fish tank. You put a filter in, you do a water change, you put some plant species in there, you put some animals in there and things like that. And then if you were to take away the filter, if you were to take away the sucker fish, take away the plants, don't do a water change, you'll pretty soon notice that you'll start to see the balance of that fish tank change pretty quickly to something that turns into an algae that does require some management and attention. So it's not too dissimilar to that. I've just got some notes I forgot to. I'll just put them up. I wanted to. I just hope that it's okay to talk to you about some hope in this, because it's so overwhelming. It's overwhelming for me as a marine biologist, and I can only imagine what it must be like to not have the facts and the knowledge in front of you as well. My notes up. This is a video of a cuttlefish at one of the reefs, Windara Reef at Ardrossan. And I just wanted to say just some key messages up front is that, you know, restoration isn't just possible, it is something that is actually happening. And we have got some really powerful allies in nature. Those are things like oysters and seagrass and the kelp that are working to help us with this problem. So these ecosystems that I speak about, they've got this incredible ability to recover if we can remove that threat. Some of them do, they'll naturally recover, and if they don't in other instances, it just means we need to give them a little bit of assistance to get them going. The oyster reefs that we've restored in South Australia are already giving back to marine life. We've published 2 papers on that now. And if we continue to work with nature and not against it, that's really our best way to build resiliency into our marine ecosystem. And yeah, just really important, it's not too late to turn things around. No, absolutely. It's a really important message. I have to coordinate these 2 screens now. So just quickly, a little summary, I guess what Faith has already been saying is these algal blooms, whilst they're increasing threat to our marine environment, they are exacerbated by these warming waters, those excess nutrients in the system, but also the ecological degradation as well. And so I'm really grateful, and I think it's absolutely correct, that the funding at the moment is gone towards the emergency response, supporting businesses, the aquaculture industry, fishermen, tourism, absolutely, that needs to be there. And I just want to ensure that we keep the conversation around recovery planning and future recovery, putting restoration, marine ecological restoration into that conversation, because there is so much evidence that shows that shellfish reefs, the kelp, the seagrass, can actually directly mitigate some of those impacts from the harmful algal bloom that we're experiencing at the moment. So they reduce the nutrients, they improve clarity, and they also help us to rebuild the marine species and biodiversity, which is such an important part of helping these animals that we're seeing die and washing up on our shore to bounce back and recover after this event. So just, I'll run through a few just specifically. The oyster reefs is probably the main ecosystem type that I've engaged with the York Peninsula community on. It's an ecosystem that we have quite a bit of research now to suggest that we've lost about 99% of this particular reef in South Australia, so 1% remaining. So if you could imagine about a third of the coastline, this is some work that you can see in the green. These are areas along the coast here. We have high confidence because there are so many historical fishing records and maps and other evidence, multiple evidence to show that there were oyster reefs there. So this work has come from some really important researchers that have been helping to fill the gaps for us. And so this was really the reason why you can see here that York Peninsula was a clear site for us to begin the process of building the first shellfish reef in South Australia, and it still today is the largest in the southern hemisphere. So yeah, I'm grateful for all the community support for doing that off the coast here. So these oyster reefs, they were built just quickly with limestone rock that really mimics the natural seabed. Limestone is just a historical old seabed, and so we just are putting that back into the ecosystem, and we use a lot of that rock. We use a lot of recycled shell, and we did it over two lots, and we were trialling a few different techniques and things like that. So there were some reef bowls made out of concrete structures put into that first phase. But all of these little darker patches are all the 159 different reefs. They're about half a metre off of the sea floor, so they're really low profile. And the reef is, like the evidence shows, so we've been monitoring this reef since before we even built the reef. So we've got a really long data history from this site. So we've got pre-building, we looked at the biodiversity there, we looked at the oyster population, and so we've got this really nice data set that we can continue to use to see how this reef is tracking along as it grows. So it's going still in that direction. It's got some really great species on there. The probably most recent survey that we did on the oysters suggests that we're probably sitting a little bit lower than what we'd like, and that there might be some potential adaptive management to put into that. And it's not unlike any other like tree planting or other sort of land-based restoration program where you have to go back, do some weeding, fix some fences, maybe remove the roofs, etc., etc. It's exactly the same. So, you know, we're learning a lot as we go along. This is some images of, just so that you get a sense of around what the reef looks like. It's, I guess the characteristics of this particular reef was that we saw an incredibly high density of oysters on the reef initially, and we were so, and the oyster farmers, oyster growers at Stansbury will tell you, there's a lot of recruitment in the water. There's a lot of baby oysters, native oysters that are out there, and even just by putting the rock into the water, we got hundreds and thousands and millions over the whole entire area of these baby oysters that settled onto that rock. And so what the data showed is that initially in the first year of monitoring, you know, that the amount of oysters per metre square was in the sort of 200 to 600 oysters per metre square. Now that's great when you consider that the benchmark of success for this type of work is 50 adult oysters per metre square, and that's based on surveys of known oyster reefs that we still have. So that we're using the ecosystem to help us to have I guess a picture or an idea around what we're expecting. In terms of recovery and timeline, that's really just us learning as we go along, and what we're finding is the different reefs that we're building in different areas. So we've done now 4 different sites, here, Glenelg, O'Sullivan's Beach and Kangaroo Island. They're all growing and responding differently, which is really interesting. Now, those oysters are probably, from the last monitoring event in 2023, we're sitting more around some as low as 7 on some of the reefs to 98 oysters per metre squared, and they are not adults either. So we're definitely looking, I'm thinking that that reef we might try putting out some fresh mulch or something like that. The oysters seem to want to grow underneath the rocks as well, which is really interesting, and it differs from what's happening on the other side of the Gulf as well. It's making a home for a lot of species, so the Department of Environment and Water continue to go out and do some of these baited underwater video surveys, and so there's There's swimmer crabs there, there's loads of leather jackets there. We've seen schools of whiting, there's a Port Jackson shark there. You can see around, in and around the reef as well, there's a lot of really healthy pinna. So that's the razorfish as well. So the ornate powerfish. So yeah, the reef is already got a lot of life going on there. There's a lot of abalone, sponges and things like that. It's probably lacking a lot of that canopy forming kelp, but I think that's probably a result of just it being a lot lower energy water currents and things here, and so we're seeing a lot more sedimentation and a lot of that kind of like what we call sort of turfing algae. I don't really know if you can see that very well, but that is evidence of a school of whiting that has been seen there consistently. And on our reefs in Port Phillip Bay, in Victoria, and in other areas, like we're seeing really high numbers of juvenile snapper that seem to really like at kind of like when they're sort of 3 to 4 years old, they'll move up the mud flats and they like to go and eat the oysters and things on that reef. So the oysters are a really important part of the food chain. They are also like a key species to help combat this harmful algal bloom because they are filtering about 100 litres of water a day. So that's a bathtub every 2 days just for one oyster. And so they are eating, as we saw today, they're eating that Corynea species. So you put in a whole bunch of these oysters back into the system where they should be, bump that up. We've got a natural ally there to help us with that. And they also help to reduce, improve water quality and things like that. So really my call to action for this is really to scale up reef restoration and get your support to do that. And we do that by using limestone. I think we have a really good opportunity to engage fishermen, the oyster growers and things like that in helping in that recovery process. The restoration economy is huge and there's a lot of opportunity for a lot of people to get involved in doing that. And this is a lovely picture of the York Peninsula community that helped with clean and bag shells for us. The Glenelg Reef is a little bit smaller in size. You can see where it's located. It's a 5-hectare site. These are, just briefly, this is one of the best performing reefs in the whole of the country. We've got over 2,000 oysters per metre square on those reefs there. And you can see from these images, these were just after 2 to 3 years, we're already starting to see such a huge transformation. And then just most recently, look at all those oysters that are encrusting on the top. We're getting some really nice native calopo growing on that. And it's really transforming in such a much shorter period of time. When Dara's 7 years old, it's only been a couple of years old, 4 or 5 years. And one of the exciting things that I really have enjoyed discovering about this is that seagrass is returning, and that is, anyone that lives on the Metro Coast knows just how important that is. There's been a lot of effort to restore seagrass, and I'll go into that in a little bit. But initially, when researchers at the University of Adelaide went, they were just documenting, there's a few little seedling patches starting to grow, and we were getting excited. And that was all in the shelter of the direction of the currents. And one of the things that's limiting seagrass recovery along the Metro Coast is it needs sheltered seafloor bed to be able to allow the seedlings to settle down and start to form roots and get growing. And I don't know if that would go, yes. So now you can see we're talking about more than just little seedling patches. These are actual growing patches that are, quite sizable now, that are growing in and around the reefs. So all of these dark patches, they're all seagrass, which is incredibly exciting. There is a few sites that we are considering in yellow, and so we're just doing some some further work there, but I do think that there is an opportunity still to, even though Windaris at Ardrossan is recovering a little bit slower, I still think there's incredible opportunity to continue to trial different things, because just like farming, it's different seasons, different times of the year, different years, we're seeing different things happening. So yeah, definitely lots of potential there along this coastline. Another species that I think is really important for ecological restoration in this conversation is around seagrass beds. And along the Metro Coast, we've lost about 6,000 hectares of that seagrass. They are incredibly important they stabilise sediment, they are sequestering carbon, they're also producing natural algicides as well, and they're improving water quality and absorbing nutrients. So all the things that can help with keeping these future algal blooms down. There are a number of people doing some incredible work in the seagrass restoration space. South Australia has the largest seagrass restoration project in South Australia. They are restoring amphibolous species, so those sandbags that you were seeing, they've got this sort of grapple hook in their seedlings, and by putting these just hessian bags filled with sand that community members can do, and putting them over the side in strategic locations, what they're finding is that's giving them enough of a stable environment for them to settle onto and to get going, and they're seeing some really good results in some sites, which is great. And then the Ozfish Seeds Snapper project as well is something that anybody can get engaged in. It's an opportunity to restore and help with the restoration of ribbonweed, which is a Posidonian species. You will have no doubt, if you've walked along the beaches around New Year's, you'll see these seeds, these fruits, wash up on the beach. Community members are collecting them, they're growing them in a hatchery, stitching them into hessian bags, and they've also been placing them now and getting some good recovery there as well. And anyway, this image just shows you on the Metro Coast, only because I have a bit more certain data there, but there's a whole opportunity under the 7 metre mark where natural recovery hasn't happened. I think this is why I put this image in actually, is that the water quality improvements along the Metro Coast have led to an extraordinary amount of natural recovery. And I just think it's really important to note that. It doesn't always have to take this real active building restoration. Sometimes it's just removing the threats and doing some things that enable those things to naturally recover. So improving water quality was a really important one there. And just, lastly, kelp forest as well. So there is, I know along the Metro Coast there's been an incredible loss of kelp. We're hearing stories of kelp being lost to this algal bloom as well. And so, there are areas already where we have lost a significant amount of these kelp forests. So the main species here is Eclonia radiata. It's called the golden kelp. Likewise, there's some really great work being done. The organisation that I work for, the Nature Conservancy, has been doing some really great work in Port Phillip Bay, where they are cultivating the seeds in a hatchery. A lot of the juveniles are settling onto some twine and they're putting it out, and you can see this is all some of the growth of that. And so these kelp also have a really important part in reducing nutrients and improving biodiversity as well to help in the recovery. I just wanted to end with some recommendations just to go away with. It's really important in this conversation around recovery, future recovery, to continue to invest in large-scale marine restoration in the Spencer Gulf, in the Gulf of St Vincent, and it needs to be commensurate with the current and the future risks and the scale of this impact. We are getting not a lot of money. It comes in dribs and drabs. We need a proper programmatic funding in the sort of hundreds of millions of dollars. Just like road building, the reason this project was came to York Peninsula was a regional economic development opportunity. It absolutely is. There's a lot of people that need to be involved in helping these projects to get up and get established. I really want to urge that we come together, we collaborate, bring multi-sectors together. I think restoration needs to be done with the environmental organisations, the fishers, aquaculture industry, and plan this recovery plan together in a way that makes sense for everybody, and everybody can get involved as well. And then just lastly, I think we really need to just embed restoration into the conversation around recovery once, you know, obviously we've got this first $28 million to go to emergency response, but yeah, we really need to embed it into our future recovery plan for this algal bloom, and also just recognise that it's a critical component of making sure that our ocean is resilient into the future. So thank you so much.
Thank you very much, Anita and Faith. We do have time for a couple of quick questions, so if anyone wants to ask a question, please raise your hand and I'll come pass you the microphone, and Anita and Faith can give some scientific answers. Please bear with me one sec. If you don't mind introducing yourself, thank you.
Hello, David Blair from Morbay. I guess first of all I'd like to say a big thank you to you, Faith and Anita, and also others that aren't here that have been doing a tremendous amount of work on this, and without your input I think we'd be way behind where we are now. First question to Anita. Your oyster restoration, have you been back to see how the oysters have performed post this bloom? Because the pinner beds at both Stansbury and Port Henson being decimated, and I was just wondering what impact it might have had on the oysters.
That's a good question, and I was meaning to put that in, and I forgot about it. But I think the last that we checked at Glenelg, I haven't been to Windara. I did speak to Stephen Andrews about potentially helping us to get some footage there, and I do plan to go for a dive. I'm keen to see what's happening there, but I guess given also the low oyster numbers, it's not as been as important. But I think there's other species there that, like the abalone, the sponges, and all that other stuff. I'm really keen to see what's happening there. On the Metro Coast at Glenelg, they have been as of April. They were still around. Things have changed since then, so I'm keen to just continue to check in. The Department of Environment and Water are going to be continuing on with more large-scale monitoring later on in the year. So I think the community still is playing a really important role in just doing these rapid assessments so that we can track what the impact's doing to species at different times. But also being heartened to hear that some of the Algae oysters and the oysters that are growing in the aquaculture facility are plump and doing well. So oysters are a very resilient animal, which gives me a lot of hope.
Thank you. Just quickly for you, over the last few weeks at Wall Bay, the water clarity has improved quite dramatically. However, when it is calm and clear, you can clearly see what appears to be a white filamentous, almost like a detritus material widespread in the water column. Is that likely the remnants, or is it another algae, or do you know, or can you help us out here with what it is?
Okay, so there's a couple of things in that, isn't there? So first off, the water being clear doesn't necessarily mean that carina numbers are a huge amount lower, but it does mean that there's less stuff floating around with it. A lot of the watercolour is actually created by other things that are floating around with it in the water, and so it's just worth keeping in mind that your can still be high. Now what you're seeing is what is often referred to as marine snow. It's a nice word to talk about rotting stuff. Okay, and I've been told off for using the word stuff because it's not very professional. Oh well, that happens. But in this case, usually those grey are rotting fish, rotting seaweeds, and other such things. And so at KO, some of the guys were talking to me about up to 2 inches of that in some areas, whereas other areas have a scattering.
Okay. Stuff I was saying is, it's not like, it's visible to the naked eye, but it's almost microscopic. You've really got to look at it closely. So it's very minute. So you're saying it's probably dead material.
Yeah, so what happens is when the fish dies, a lot of other bacteria eat it, and often it's sulfur-reducing bacteria and things that cause botulism and all sorts of interesting conversations around those. But that bacteria is what's forming the detritus. It's quite gross, but part of the system.
Yeah, thank you. We have one more question down here, so go to the first person whose hand I saw. If you don't just mind introducing yourself and asking.
Thanks very much. I'm a shacker. I've lived in a shack, my permanent home now for the last 20 years. Been there since the mid-50s. And every morning I go for a walk, and it's been very distressing. What I've noticed just recently is razorfish being washed up. And we haven't had an exposed reef yet, and I'm not too sure what's going to be looking at. I don't think there's going to be much there. Seagrass is moving out. You look on the beach and the green water is becoming wider and wider. And my question is, really, if the Murray didn't flood, would we have this problem?
If the Murray didn't flood, yes, you would have this problem. Okay, so there is a conversation around the River Murray and its contribution, and as you would appreciate, we are a long way from the mouth of the Murray here, and so is Roe. And so best we can tell, the Murray flood was 2 years before this bloom. The upwelling that they think might have brought the nutrients back was a year before this bloom. Nutrients do not hang around in active coastlines without causing some other bloom, which didn't occur, in the time period. So as far as I can tell, while ongoing land management issues right around the state may have contributed to increased nutrients in the base of our gulfs, and obviously cleaning up Adelaide, discharges have helped with restoring seagrass and restoring pinna also in Adelaide. Pinna has taken a hell of a shock. Doing those things help improve the resilience of this system, but as far as one river flood causing a mega bloom across 2 gulfs over 6-8 months, maybe longer now, we're thinking that didn't happen. It may have been a fraction of a percent.
Right, thank you very much. Although we're running out of time, Faith has very kindly offered to take a few questions after the formalities finished tonight. Letitia, were you going to have a quick word? Alright, as Letitia comes up to the... Is there a need to kill it, by the way, so she's made an extra effort to get here tonight. Just as Letitia comes up to close proceedings, I'll just note the pamphlet and flyers that you would have seen on your seats has a link to a council webpage where we're sharing all the official news sources via the state government, and it also has a link there where you can submit direct feedback to council to help inform our ongoing advocacy, because we are working really hard on behalf of the community to make sure that now there is some money available, York Peninsula is not left behind, gets our fair share. Because, yeah, as much as tonight's been informative, it hasn't been all good news, so there's every chance we're going to need it, and we're going to make sure that we get it.
Hello, that's working okay? I'm Letitia, I'm the Environment Officer, do know quite a few of you. I actually know Faith from 2005 when I was the Water Watch Coordinator, so that was a community water monitoring program, and Faith and her mum Perry were huge supporters of that program and having community involvement in being able to do that monitoring program and have those early warning indicators of different changes in the environment. And so council has we'll be looking to purchase a microscope so that we can start having a community monitoring program here on Warrandyte Peninsula. And we're going to have face guidance, so she will be coming over to train up 6 lead practitioners that we can then expand. Those 6 lead practitioners can then train up other people. So there will be more information about that, an expression of interest to become involved, because you know, it is overwhelming, like Anita has said, and so it helps with your own well-being to be proactively involved that way. But it's also data that helps show the trends over time, and like I said, can be that early warning system or give a reason for the state government to expand their monitoring program. So it is great, like, that the state government has got more funds now for monitoring, but we can still plug the gaps through community, and as Anita and Faith have said, that you know, it's been a really important role, all of our eyes on the ground, to inform the response. So now I'm just going to close, so there will be time to mingle after and speak directly to Faith and Anita with any of your further questions. But just to close, I am having Sonia return just for the very end, because there is a very important creation story for the shark, and obviously that's been one of the